Is it visible? Yeah. So, hi guys, I'm Veeru Shajit. Little formal introduction about myself. I am in the fourth year and see, I'm in CSE core, and currently I'm interning at Postmark since Jan. And for today's presentation, I am going to talk about how the data is being handled at large scale. So, from my internship experience for these past few months, I gained quite some knowledge about how industries handle the data when we are dealing with a large amount of different types of data, like each user events or the product details and the images for each product or something, how we handle them and how they are used in production for recommending the users better products using the data. Like for example, you might get embeddings from an image and the metadata of a product in order to represent a particular product's embedding in a vector DB, and then using that we can recommend them better to users. So how different types of data are being handled and how much are they being valued at each step of a pipeline overall. So let me give you a small introduction about Postmark before going into data, because the types of data and the stuff that I'm going to speak about are in regard to this platform's jargon. So Postmark is a social e-commerce website. It is similar to Amazon and to Instagram. Like say, uh, we can buy products and as well sell products on Postmark as a user, and we can also have the option to like or comment about a product, and you can subscribe to a particular seller's page wherein as they post new products on their page, we can get suggestions from them on our feed. And other than that, we also have some a few other features, but this is an overall scenario how Postmark deals in the e-commerce platform. It is currently operational in US and Canada. It's not available in India. And yeah, that's it about Postmark. So let me talk about how to perceive data and what type of data are we getting as input and how to process them. And in the pipeline that we design, how can we segregate them to not have a case of overrating or getting too much traffic and not able to perform proper operations on the data that we have. So like before getting into the data, like I mean like the processing of the pipelines, I like to say like we need to understand where the data is being acquired from and what type of data are being inputted from our the website. So I'm going to talk about the particular perspective of how the data from the user activities in the platform is being processed in the pipeline that we have. So regarding that aspect alone, from after getting into Postmark, I got the idea like how much are we being tracked in each website. So like each scroll we do or each page we view or the likes we if we like a particular product or comment about a particular product, if we order an item, if we negotiate an item. Also, we have a feature like yeah, before purchasing an order particular product, we can also have the option to negotiate a product. So these are just separate events that a user can do, and these are being recorded in the servers in the backend. So how to decide what type of data comes in which type of category? So there's basically two types of segregations that you can think of. Like one is OLTP and OLAP. OLTP is online transaction processing and OLAP is online analysis processing. So what is transaction processing is, you might say like, uh, just a second. OLTP is basically like the day-to-day transactions, operations that we do, like, basic CRUD operations that we do in the platform. Like either we, buy a product or we initiate a negotiation or we like a particular product or we comment about it. These are being stored in the server, and these type of actions needs to be persistent in the server. like the ACID transactions, ACID properties needs to be kept intact in these type of actions by the user. So this is what OLTP deals with. OLAP is the part wherein, after we have some data from our website, we need to analyze them in order to provide a better view and better experience for the users. So this is basically the analytics part, the data analytics and ML engineering part. So OLAP deals with the data that is collected from the users. We query them, and we get the insights from the user interactions. So OLAP mostly will be dealt by the employees in Postmark, and OLTP might be dealt by the users who interact with the Postmark's website. So these are two different parts that needs to be, separation of concerns needs to be there. And other part is batch versus stream processing. And in batch versus stream processing, there's a basic, you can directly get an idea from the name. Like batches, like once over a period of time, the data gets collected. Say end of the day, we need to produce a report. So that comes under batch processing. Or say we collect n number of data, and if we have those n number of data, then it is being processed. Stream data in the sense is like, as the user interacts, we need to record them into the server, and that needs to be reflected in order to have the particular process that depends on this data needs to be initiated or something. So for example, I might say, like, for batch processing, what we do is, say a user is there, and I need to get what products are most, you know, can be recommended to me based on my previous interactions. So say for the last 1,000 interactions that I did, I need to have a representation of that, of what I did in my previous interactions, to in order to represent myself to get the products that are being recommended to me. So in the process that we have, say around 200 last interactions for a user is being recorded. Then I initiate the process of creating an user embedding for these last 200 processes. If the interactions doesn't hit the 200 number, we don't need to create a new embedding for the user. So this might come into the batch processing type. In the case of stream processing, as the user likes or views a page, that needs to be recorded, and they don't have the case of having that much latency to being recorded in the database. So these are uh, another type of two separation of concerns that needs to be dealt. So then we'll move on to the second. Yeah. Data analysis and the pre-processing steps. That is, a overview, like before going into the implementation of machine learning models that you might do in hackathons or mini projects that you do for your own personal things. Just get a sense of what the data that is being used, that you are being, as input that you got. Like you need to get the understanding of the different attributes in the data set. How does it influence the particular output variable that we need to predict in order to, from this, say you have A, B, C, and you need to predict D. So how much influence does A have on D needs to be understood first in order to give it as input for an ML model, and that in turn has some better understanding of what model to be used in the first place. And as well the process of data pre-processing, wherein you need to get the data, and then before inputting into the analysis part, you need to have some works being dealt in the data, like normalizing it, something before hot encoding it, before having it inputted into an ML model. Those are some few steps that need to be covered. And regarding data analysis, I'd say, like, from this example, this is from a pick in Amazon. Like, if you take a particular product, and you will have suggestions being showed for you, like this product can be paired well with this particular products. So we are currently looking at Postmark how to show the recommendations for a particular product to be paired with better. So for this, we need to create a better recommendation model, and for that we are currently performing EDA, that is exploratory data analysis. That part is where I explained to you, like understanding the data. So in this one, if you see the example, like for this particular product, like a watch, what products are being recommended by the system and how much are it getting converted into successful orders. So we do have that data from our previous, user interactions. Like user bought from a particular seller, like he bought a shirt and another shirt in the same from the same seller, and it has been converted into a successful transaction and order. So we do have that data. Now we need to get a sense of how the products that were being bundled together, paired together, how are they relevant to each other? Like, are they from the same category? Like, do majority of the users prefer same type of two shirts being bought from a seller, or does he like to pair the shirt with a pant or a watch with the shoe or something like that? So by doing this, we'll get an idea about how the category of the product, like whether it comes under the shoes or shirts or watches, how category attribute is relevant to this particular use case of recommending that product to the that this product can be paired with this one. So you'll get a better idea by doing this particular EDA. Like, does the category field is necessary in order to be given as an input to represent that product for producing an embedding for it and then having it stored in the vector DB and checking how relevant it is to the user or something like that. Those are the next part that needs to be covered. Before that, to produce the embedding, is it necessary for this category being included? So this is one case wherein I found that data analysis is a much more important step before entering into the machine learning and training processes. So yeah, that's it about data analysis part. Now I will deal with the data pipeline that is being implemented in Postmark. So most of the services that you see are from the AWS. So regarding this, I will give you an idea. Like this is the part wherein the users interact whether in the mobile app or the web application. We have two separate pipelines. One is for the batch processing, and this one is for the streaming processing. So this is the part wherein I mentioned the separation of concern is being handled. And also we do have the OLTP process being done here and OLAP process being done in this part. As I explained, you'll get a better idea of it. And now let me start with this part, which is the batch processing. So application servers are the ones that has the proper backend server of the Postmark, which deals with the user transactions like buying a product and placing an order, or a user posting a product or something like that. Whatever needs to be a source of truth that we need to refer to, that this is being recorded and this needs to be persistent data shown in the website forever or something like that. That is being dealt in this part, and that is stored in the MongoDB. MongoDB is a database wherein you store the data in the format of JSON. So MongoDB stores in that format. And we do have a ETL. ETL is a thing that is like extract, transform, and then load. That is, we convert the JSON formatted data into the columnar format. That is the tabular format that we use in SQL and stuff. Like you can see if you have read the EBMS, you would get the idea of tabular data and the difference from JSON data or something like that. So ETL performs, we have some scripts to be run. So it will map the particular attributes in the JSON into columns and the values that we had in the JSON as the rows. So that would be transformed into and then stored into Amazon Redshift, which is a relational database. And this part, after getting stored into the relational database, we do have the tables for the different, user data, product data, and user likes data, user comment data, user order data. Various other tables are being stored here. And these can be analyzed by these tools that we use, like Jupyter Notebooks and Databricks. And these are the different tools that can be used to visualize and analyze the data that you have stored in the relational database that you have. So this is one part of the processing. And in here, the OLAP, that is the online analysis process, is being taken care by this part, Amazon Redshift, and by these tools. And the OLTP, which is the transactional processing that is being dealt in the server and by the user interactions that are being recorded and that needs to be intact to the asset properties, are being handled in this particular part that interacts with the MongoDB. So this part covers the batch processing. And now I'll come to the part of talking about the stream processing. This one is like these are the data that doesn't need to be persistently stored in the website, but needs to be stored, stored in a different area to get us better understanding how the user performs and user behaviors. So this one tracks what the user views, what the user clicks, what the user likes, and stuff like that. We have active event listeners in our website, and for this, we have the as the user interacts with the website, we get these data, and these are in an enormous large amount of data because for each user, if you are viewing the screen for even a minute, there's been a ton of data being processed in the back, and that is being transmitted to the tracking server from your client side, that is the user side. So once this huge enormous amount of data is being inputted, we have this Amazon Kinesis. This is somewhat like a queue, like it processes, channelizes the data that is coming in a huge number, being processed one at a time or something like it schedules them and sends to the next stage. So the next stage is Amazon EMR. This one is for data cleaning and then enriching the data. Like, I can give an example like in the backend, we have some specified fields being written like for the user ID it should be a string, user name it should be a string, and like amount of time you should be in number, like some specific data in some specific format of the data should be there, and that is what being stored in the data set at the end. So Amazon EMR ensures that these data that are coming as input are intact and adhering to the data format that is being in the schema that we have defined. So it takes care of that step, and as well enriching the data. That is, once the user interacts, we just get the IP address of that particular user, and from the IP address we can map them to the location and the locality and the time or something, like enriching the data that we already have. So using these additional fields being added to the uh, data that we have and not being shipped from the user directly, we are adding it in the next step that we have in intermediate. It saves some money, and then as well enriching these data, we get a more clear idea about based on this particular region, we get more orders on this particular product. So maybe we should store more similar amount of products in this particular area or something like that. So having the enriched data might get us a better idea about the user behavior as well. So then they are all stored in the S3 bucket. Amazon S3 is data lake type of format, a data lake type of storage place, wherein it is much cheaper compared to the Redshift and MongoDB, and it stores in the format of files. So as of now, these store files, and this one stores the tabular data. This one stores JSON formatted data. So the file type that is being stored is Parquet files, PARQUET. Yeah. I was also confused by the spelling first time, so I just wanted to spell it up for you guys. This is a type of CSV file that is compressed and represented in binary, and it is much more efficient in terms of storage and also querying them. It is much faster. So we use the Parquet file format to store them. And once this Parquet files are stored, we use Amazon Redshift Spectrum. This is a service that is offered along with the Redshift, wherein we can directly query the CSV files and turn them into tabular formats, that is SQL type tables. And by having them stored as well in Amazon Redshift, then we can query them with the same analysis tools that we have like Databricks and Jupyter Notebooks. So this is the overall overview of the pipeline, not getting much into detail, but just giving an idea about how massive data is being handled and how they plan the design such that it is decentralized. Like we don't depend on a single server being hit to store all the data. We have different servers to interact with the data that needs to be persisted on this website, and the one that is used for the analysis part of the users, and as well the different types of databases that we use, like MongoDB to store the large amount of data in a JSON format, which is much cheaper. And Amazon Redshift is much costlier, so we don't directly store them as tables, and it is much, causes much latency to write into table formats when compared to JSON. So we have this extra steps to convert them and store that in the Redshift. And S3 is a much cheaper one, and we have we can store large amount of data in a less cost. So we use this to store the streaming data, which is much more massive in scale compared to this data. So this gives you an idea about how the data is being dealt in scale. And other than this is just some basic points like data governance and compliance. Like whatever application that runs with massive user data that is being stored, we need to follow some regulations in order to not face any legal troubles. So that is the complaints part. Data governance is like defining properly like what user can handle and can access which type of data. Like for a end user, they can view the data that is defined for them, that is being recommended for them or something like that. But for an admin or for a employee at Postmark at different stages, and for each team we have different set of tables access. I don't have access for few of the tables that the web team has, or the web team doesn't have the access for the tables that I have as I'm present in the ML team. So we do have to have the clear idea about, if being in an organization, which type of data can be accessed by which user types. That is basically RBAC, that is role based access control. So based on the role of the user, you define what type of data that they can access. So that's basically data governance. And regarding the complaints part, you need to follow some regulations. These are the famous ones, like GDPR is in Europe. So if you are having the app in the Europe, you need not be a company that is based on Europe. But if the users in Europe are using your application, it needs to follow these regulations. And for health data, it needs to follow this HIPAA. And for financial data, it needs to follow this regulation. And for compliance, like you need to have some specific user, specific data that needs to be collected and stored. For personal, you need to define what type of user details are being stored, and that needs to be disclosed to the user as well. And other than that, the data minimization is like whatever data that you require that needs to be alone uh, got and then stored in your systems. And whatever data that you collected for this particular use case, it should be maintained. Like if you are getting a phone number for your web application, that phone number should not be misused for any other purpose than the one that was defined in the web page. So that is one. And then security and encryption, that you need to keep intact of the user data that you have in your, this is cybersecurity related stuff. So yeah, this is basically the stuff that you need to take care in order to imagine if the data is being scaled to a much higher level, and in a web application that deals with millions of users, what all steps needs to be taken care of. So just to give you an idea, beyond the projects that we work on that deals with data, how companies deal with them, and how much larger in scale that they need to think of balancing the latency, splitting the traffic and the requests to not overload a particular server, and how to design the pipeline and what all steps that needs to be taken care to not overstep any regulations or something like that. So yeah, this is basically that I needed to share to you guys about the data and scale. Yeah, that's it. Thank you guys for listening to me. Hope I gave
Thank
you
you
an
so much,
informative.
Veer, for sharing such valuable insights. And now, participants, please feel free to ask all your questions to Veer.
Do they put in the chat or it doesn't stop me sharing?
Uh, Either you guys can put in the chat or you can directly ask the questions. Anyone has any questions?
Also, sorry for asking it now. Like most of the participants here are from the first year or second year. I mean, which year are they from?
They
I
are
believe they
first
are
year, second year,
freshers.
and third year. All 3 years are there, first,
Ah,
second, and
okay.
third.
Yeah. Hope what I conveyed made some sense. If not, sorry, guys.
Anyone has any questions? We encourage everyone to stay interactive and engaged throughout. Okay, then moving forward, we now introduce our next speaker, Mr. Raghav Kaushik. He is a technology mentor and AI practitioner known for helping students about modern AI-driven development practices. He has worked extensively with AI workflows and data-centric problem solving, guiding learners on how to apply emerging technologies effectively in real-world scenarios.
In this session, he will explore the idea of depth over breadth, why it matters in the age of large language models. Understanding this balance is becoming an essential skill for modern engineers, and we are excited to gain insights from his experience today.
So now let's welcome Mr. Raghav and over to you, Raghav.
Hi everyone. Just a minute, I'll share my screen. Is my screen visible? Is my screen visible? Anyone?
Yeah, it's visible.
Yeah, so yeah, I'm Raghav Kaushik. I'm a fourth year computer science student at VIT Chennai. Currently, I'm a research intern at Microsoft Research, working with multimodal LLMs, mainly multimodal reasoning. So my presentation isn't going to be as technical as Veer's. It's going to be pretty chill, but something that I thought I should address to the next, set of students at VIT. Especially with the rise of like coding agents and with language models and with Anthropic dropping the next Claude, model the next week or the next month, and claiming that we'll wipe off 90% of software engineers and stuff. So I thought it would, amongst the fear mongering and the current AI situation, I thought it would be important to address this. So I'm going to focus on why depth is more important over breadth and why it matters, especially in the age of LLMs. So, like the term vibe coding is very famous now, and most people use some sort of coding agents, and it's pretty popular. And most of these coding agents make a lot of money only from enterprises. So inside companies, from what I observe as well, most of them use some sort of LLMs or coding agents to actually run code. But what matters exactly when you actually use LLMs? Should you use LLMs to write code, or how should you use it exactly is something that no one really talks about. So, many claim themselves, for example, I'm just going to take the example of GenAI engineers. So, that's getting pretty, viral, and people are just calling, random people call themselves GenAI engineers right now. So, who's a GenAI engineer? And like, by just calling APIs, can you really develop applications that will, stand tall through time? So, like for example, let's just take a simple example of fine tuning a model. Almost everyone would have done a project. Everyone who's into AI would have done something with fine tuning. But what about the hyperparameters? Like, what happens when the model gives you bad results? People call themselves a Gen AI engineer, but for example, if they use something like low rank adaptation for fine tuning, what happens when the rank changes, or what happens when they use a particular optimizer instead of another? And what happens, and especially what happens if the model breaks? Like if you don't get good results, how do you improve? Do you start the process all over again? Do you go and change something in the data, or do you change the model itself, or do you just change some parts of it? And also, efficient inference is becoming very famous, and dealing with GPUs, and you might have heard it in the news that industries are your company big tech companies are investing billions of dollars into data centers and getting GPUs from Nvidia. So knowing how models work almost helps you avoid pitfalls almost 99% of the time. Yeah, AI does help, but it doesn't eliminate deep work. For example, before the age of AI, um, the survey suggests that software engineers spend anywhere between 35 to 50% of their time in debugging. But even with AI, and with all these claims of making people more productive, debugging is still a significant portion of engineering effort. Recent surveys and studies suggest that developers almost spend 60 to 75% of their time identifying and dealing with issues rather than writing new code. So, like, yeah, of course, the coding speed has gone up. Maybe you can develop applications but debugging takes up 4 or 6 hours. I've seen people in software actually do this. And that is why it is really important. So while debugging, you can still go and ask, if you use Cloud Code, for example, or any other agent or model, you can still go and ask the model to fix the error for you. But what happens to the token rate? And does the model really go back to the correct place and fix the code for you and it runs it again perfectly? No, not really. So yeah, of course, there are bottlenecks with agents, like they can't solve long horizon problems. They're not very good with memory. Exceeding of context length is another problem. And of course, price is a major bottleneck as well. Like everybody cannot afford $1 for 1 million tokens. If the I mean that is the price for the most expensive model right now. So yeah, AI helps. You can use AI for coding, but the debugging part, at least you should understand what's happening first and then use AI so that your productivity actually goes up. And in the age of AI, if AI can do everything tomorrow, like for example, there are claims of reaching AGI, but people in research actually we don't believe that will reach AGI anytime soon. But all the management people make these claims of reaching AGI by 2026, by 2027 or something. AGI will happen when there is true general intelligence. Nowadays, language models are very well trained to fit in to actually do in distribution tasks. That is, if they are trained for task XYZ, they do XYZ very well, better than any humans. And that is what is happening with coding. And if you look at Anthropic's latest take-home assignment, Anthropic is if you don't know, Anthropic is the company that developed Claude, which is the most used model for coding right now. And Claude Code is like the most famous coding agent, and it generates the most amount of enterprise value right now for Anthropic. And yeah, it is better than Codex. It is better than Gemini 3.1 Pro and all these models. So in the age of AI, if everything can be done by LLMs, what do we essentially do? How do we stay relevant? And if all these claims are true, and if one day we really reach a place where we reach AGI or we have reached AGI, how should we even survive? Or before that, because every year people find some or the other reasons to lay off engineers, right? I mean, even if their revenue is going down, they just claim that we have replaced engineers with AI, but that's not true. When you look at those companies, the company's valuation would have gone down by 30 or 50%, and they just to have a put up a good face in front of their engineers, in front of their investors and in front of their stockholders, they just say that we have started using AI more, and we've replaced this much of our workforce with AI. But that's often not true, at least in today's age, because LLMs are not good at doing generalized tasks. They are good at working well with distribution tasks. So what if you know who Andrew Young is? He's a professor at Stanford University and also the founder of deeplearning.ai. If you are into machine learning, I'm sure many of you would have taken his course. So he suggested in one of his talks in the 2000s, I guess, that people should ideally go for a T-shaped learning model. That is, you should have enough breadth over a wide range of things. Like, for example, if you are into software development, or into research, or into ML, you can probably just know something about everything and have really deep expertise along one single topic. Like, for example, I have basic knowledge over, let's say, web development, or let's say when it comes to software engineering. But when it comes to ML research, my depth is really high. And I've seen a lot of people who have gotten, like if you look at any interviews right now, they really focus on what you exactly know much. Like you can call APIs, of course, you can use AI to code, you can create applications, but you really understand something. Like for example, if a bug shows up tomorrow that the model has never been trained on, of course it is not going to fix it. And that is the bottleneck we are facing right now. So by definition, today AI cannot do all general tasks. Otherwise, we would have reached general intelligence. So if it's anything which is in distribution for AI, it'll excel humans, and that is what we've seen. So even if you have to stay relevant, you have to have deep expertise in at least one single area. Ideally, you should also expand your depth along different domains. But it's really important that you have at least expertise in one area, and that'll help you stay relevant. In Microsoft research as well, people have started valuing quality more than quantity. Like with all these coding tools and with the help of AI, people also use AI for ideation, which is not great, by the way. But still, they get away with things with AI basically. So the quantity that people do has risen so high. And then if you randomly pull up any resume from a first year student in 2026, and if you compare it with our batch, let's say 2022, you would find a drastic difference. In 2026, people already have 2, 3 projects. They know AI, they know web development, they know Android development, everything together. But if you actually ask a really good question, like even with when we were recruiting people for our projects department last year, I mean people had a lot of projects, but no one really could understand some parts of the code that themselves wrote. It's their project. They can understand what it does abstractive, in an abstract sense. But when it comes to explaining it technically, or let's say, I changed some part of it, or I changed just a hyperparameter, they're not able to explain what happens. And interviews have started becoming more like this. People value depth more than breadth, because language models are also good at breadth. Like if I have to develop something very simple, I'll just give it to an LLM and ask it to develop it for me. But when it comes to deep tasks that require expertise in one area, that is where you will stay relevant, and that is how you actually go about in the age of AI. And as I mentioned earlier as well, in many research labs, let's say across like Google DeepMind or Microsoft Research or Anthropic and other AI labs, or when it comes to even software companies or FANG or all these big tech giants, quantity is not valued much, and people value quality more. So a simple example, like let's take a very simple example, like a model selection problem. So I have some data. What people do is they literally pick the data set, give it to a language model, or just write the name of the data set to the language model and ask it, ask for an ML model. But okay, maybe it'll give you something like a logistic regression, or maybe something more complex. But is it more efficient? Maybe the data is linear, or maybe the data is non-linear. You have not studied it enough to actually, yeah, of course, the code, the language model can give you an amazing code. It can also optimize it for your GPU. It can write CUDA kernels and stuff. But how do you know if the data is linear or not? Like if the data is linear, your linear regression is going to get you the best result, because ideally it's just going to fit a single line. But if the data is non-linear and your model is unaware of it, you're just going to have a non-linear model. Of course, you'll have a function f of x, you'll try to fit it, but you'll have a set of hyperparameters. And if you look at the code from language models, I tried this morning for this presentation. Most language models give you a grid search. First, the grid search is like very compute heavy, and ideally it's not the way to go about things. Like even with a simple decision tree, you get a grid search. Why do you need a grid search for a decision tree? You can literally look at data and try to understand it first, and then go for the best model with the best hyperparameters if you understand what the model does. And that is more valuable. Like if the model fails, like for example, if you do develop a decision tree or a random forest, for example, that's what most AI models give, I guess. So of course, you don't, go to Kaggle randomly, maybe choose a competition, get code from AI and submit it. You get the best result? Of course, no. So what is the best? Often just changing hyperparameters according to the situation might get you the best result. And all these linear models don't work. I mean, sorry, all these hybrid models don't work that most language models suggest. So maybe if depending on the data, like for example, in this case, in the slide that I've shown, the data could be very simple. It could be just a straight line relationship. It could be just y equals x, for example. Only a linear regression can just fit it easily with a limited number of epochs compared to a non-linear model. And you just try to fit it to a linear model. It's going to take a lot of epochs to actually converge. And that is why deeper understanding matters most. Again, I've taken ML context here, but it does not effectively does not have to be restrained to just ML. It can extend to anything that is computer science related, because over the past 3-4 years, language models have gotten really good at coding. And it's almost like literally on some benchmarks, if you look at some trade-offs and some benchmark, I mean some graphs, you'll see that language models are also better than humans, better than the average human. Not of course the best human, but they're way better than the average human if they are given the right prompts and the right setting. So I've taken the example again. I'm not going into the depth of this. Like hyperparameter tuning that I suggested as I mentioned before. Hyperparameter tuning isn't just trivial. It often requires deep insight. And of course, choosing the right optimizations and bias variance trade-off is there. People, I mean, I've seen people call themselves Gen AI engineers without even knowing what bias variance trade-off is. And yeah, I mean, so basically to analyze failure modes and get into the depth of the root cause and fixing it on time, I think that is more valuable, and that is what people should move towards. So yeah, that is my presentation. It wasn't very technical, but I just wanted to leave you with this message that which I feel which is very important in this era of LLMs. If let's say LLM scale well and we reach AGI one day, at least till we reach AGI, we should be relevant, is what I feel, and we should still be valuable and try to create impact, even and use AI and in the right way possible. Yeah. Any questions, or I'd like to take up any questions if you have any.
Yeah, I have a question.
Yeah, go ahead.
Uh, Suppose a person is going to start learning the AI or whatever tech stack he or she wants to learn.
Yeah.
The AI is already far more ahead of that person. How can he or she make up and go beyond the level of AI in a short span of time? Because the AI is also doing the same thing, but at exponential speed.
Yeah. So for example, let's just take an example of a very simple example of fine tuning LLMs. Have you heard of that? Have you heard of fine tuning language models before?
Uh, yeah, I have heard about it, but don't have the depth knowledge about it. But I do have heard about it.
Yeah. Okay. So for example, let's just take building a simple ML model for a Kaggle competition. If AI is so good, without studying, without getting into depth, it can't literally beat the best Kaggle out there. And that is because of a reason. Of course, with enough iterations, let's say this, with these hyperparameters, I don't get the best result, I'll tweak it a bit. It's also technically doing something like a grid search. But basically what I'm trying to say is AI is very good at, good at some parts of everything. Like for example, if have you heard of GPUs? So for writing, there is something called CUDA, which
the pre-workshop as part of the together will be.
Come again? Hello.
Yeah, continue, please. Yeah.
Yeah. So let's say Anthropic's take-home assignment that I mentioned. I think I forgot to mention it in depth. But yeah, Anthropic's take-home assignment is just writing a simple CUDA kernel on a GPU, and if you beat Claude Opus 4.6, against that benchmark, you can literally walk into Anthropic and get a job tomorrow. It is open source. You can go and check that. I think they also have some handcrafted puzzles or situations for you to solve that Claude Opus 4.6 hasn't been trained on. So they want engineers who are better than language models in something. So I agree with the point that they're very good. Like for example, if you want to develop an app, it is obviously more efficient to use a coding agent or a language model to get the output in the best way possible. But when it comes to developing something the world has never seen, like inventing the next programming language, if language models are so good, why don't we have the next programming language invented by language models? Like let's say, even if you are interested in development, JavaScript is very famous. Why don't we have the next, language that's probably faster than JavaScript? Or why don't we have the next Rust? Or why don't we even have the next Python? Or maybe with more abstractions, with lesser latency, why don't we have a new language if language models can be really good at inventing things or making impactful things. They are good at redundant tasks. But when it comes to changing the existing paradigm, or like for example, as I mentioned, just writing a CUDA kernel for a specific GPU, they are not better than humans right now. With time, they can improve or they may not, if scaling laws hold up. So did I answer your question, or?
Yeah, thank you. I have understood the concept. I
Anything
did
else?
understand. Thank you.
Oh, got it. Yeah.
And
So
any
yeah.
more questions anyone has? I guess we are done. Thank you so much, Raghav. It was quite insightful.
Thank you.
Before we continue, we had also like to share the bigger purpose behind today's workshop. Beyond the Code has been designed as a preparatory session for an exciting upcoming event, TetherX, a 24-hour industry simulation hackathon.
Organized by the CodeChef VIT Chennai chapter, TetherX is a high-intensity hackathon created to simulate real-world product development environments where projects evolve under realistic industry conditions.
Participants won't just be coding, they will navigate evolving requirements, make strategic decisions, and collaborate under pressure, mirroring real industry scenarios developers face every single day.
The hackathon will take place on March 6th and 7th at the Netaji Auditorium, VIT Chennai, with teams competing through an online selection round followed by an offline final showdown.
To help you prepare for this hackathon, we will now be joined by two additional speakers from the team behind the hackathon itself. The next session will focus on practical prompting techniques and how modern AI tools can significantly improve productivity and efficiently in real development workflows.
Following that, the final session will explore documentation and collaboration practices that help teams work effectively in professional industry environments. These skills often make the difference between good projects and truly impactful ones, and we hope they help you approach your hackathon experience with greater confidence.
So now with this, we are passing it over to Gautam and Sriniketan.
So, hi everyone. So, I would like to talk about basic prompting techniques. So, can one okay. So, before we start, uh, today I'll be briefing about what prompting is and why it matters in industries and how organizations can you use it for reliability. Yeah. So, what is prompting? Next slide. A prompt is a structured instruction given to a AI model. So there are like three key ideas to it. A prompt should capture intent, it should improve the signal quality, and a good prompt should reduce rework and automate efficiency. Okay, can everyone hear me?
Yes, you're audible.
Yeah.
Okay, next slide, please. Difference between prompting and prompt engineering. Prompting is writing a single instruction, whereas prompt engineering is systematic design, where creating templates, testing, and monitoring them. So, prompting is basically a one time action, whereas prompt engineering is building a production system. So, next slide, please. So, there are like four core prompting techniques which I want to talk about. The main techniques are zero shot prompting, where the direct instructions without examples. Then there is few shot prompting, which provides examples to guide format and tone. So it is useful for structured outputs. Then the next one is like chain of thought, where we'll ask the model to reason step by step. So it's mainly used for research purposes and it can improve accuracy in multi-step tasks. And the fourth word is role or persona, assigning a role to a model like a legal analyst or something. This constraint tone and domain focus. So it's basically used while developing projects, etc. And another one is we can provide we can specify JSON tables or bullet formats for machine readability. So next slide, please. So now I'll be talking about the best practices for an efficient prompt. So be specific about task length and tone, and provide context and constraints. A, a good prompt should have a good context. The model should be provided with the full context in an efficient manner, and show the exact output format and break complex tasks into smaller steps and give examples to it. So after that, I'll be talking about examples. So next slide, please. Huh. So this is basically for corporation, for business intelligence, where it can be used for KPI analysis or executive summaries, etc. This is fine. Next slide, please. Ah, this is the main thing which I wanted to talk about. As many of us are, working towards placements or uh, research opportunities, uh, prompting is extremely good for code generation, even for debugging support and test case generation, and mainly it can be used to simulate a lot of data, especially while testing for scalability and reliability of an application. We can use AI with an efficient prompt to simulate a large number of users and test the scalability and reliability of the model. So next slide, please. So yeah, this is basically for marketing and sales. Next slide, please. This is basically for HR and operations, where we can use AI with a good prompting technique for interview simulations or preparing documents and job descriptions, where the AI model can do redundant jobs which generally requires a lot of human effort and time. So yeah, that's it from my side. Yeah, this is basically, yeah. So that's it from my side. Any questions?
Everyone, please
Okay.
feel free to ask any questions you have.
Okay, so can we assume there is no more questions to what Niketan just presented? I hope I'm audible.
Yeah, you're
Yes, you're
audible.
audible. Yeah.
I think you
Okay,
can
so
proceed.
yeah, I will continue now. So hi guys, this is Gautam. So when I start, I will just give a brief introduction about who I am and everything. Okay, I hope my screen is visible. Yes. Ouch. Doesn't right. Yeah.
Yes.
Okay, so yes, guys. So before we begin, I will just introduce myself. This is Gautam. I am the current project lead at CodeChef VIT Chennai, and I am also I and Sriniketan are the ones organizing this event on behalf of CodeChef. Like the MCs of this event already said, this is the pre-workshop for TetherX, our hackathon, and Beyond the Code is the title of this, particular talk, the workshop that we are having. So yeah, we had two wonderful speakers who came before us, Raghav and Veer. They were very inspirational. When I first came into CodeChef, I got their contact through them, and it's so happy to hear from them once again, even after they have went beyond and gone to industries, the internships and everything. So still, anytime I hear them speaking, it feels very refreshing and very informative. We did mention that this workshop will be of around 1 hour duration, but we have a lot of content to speak. So if that's fine for you, stay till the end so that you can learn a lot. So without any further ado, I will begin. So yes, we have to go from code to real world system. Beyond the code just means that, right? So what we are doing is we are writing code, we are doing projects, we are just doing things. But then, are we building just a project or are we building a system? Is our project really worth enough to have some value in the industry? Okay, what is its worth? Where is it recognizable? So this is the question that we should start asking when we want to upskill ourselves. So anyone can train a model. Anyone can just write a script for some particular task or build any prototype for any particular problem statement. But when you are saying you are building a system, you need to have some maintenance. You need to have collaboration between all the members. And then when you want to upscale it even further, you have to have clarity in terms of copyrights and legal compliance and everything. It should be scalable, reliable, and secure. So these three are like the very fundamental things that any system nowadays should have. So yes, we had three sessions till now. One was about data, understanding what it is, how they are processed, and we had a very good example where we presented, a nice pipeline, showed how the data is being transformed, all the operations that have been performed. And then we have the intelligence layer where, Raghavana was speaking about how we can get insights from it and how learning a particular task in depth, the T-shaped learning model, is more meaningful than, just learning somewhere. So yes, in any particular case, we have to make sure that we are using the right models with the right analysis so that we are getting better results instead of just using something because we can. Okay. So this was the two things that we learned from both of them. I was trying to write
what's up?
down. Hello. Did anyone say anything?
என்ன சொல்றாங்க? Prompting எப்படி சொல்றது? அதுக்கு
Yeah. We were just speaking about prompting. Yes, you're right. So we will be speaking further about other topics and stuff. So yeah, like I was saying, we were taking a note of what they two were saying, and it came to around 3 pages. So they talked about all these things elaborately, and then Sriniketan did have a lot to speak about AI tools and stuff. But he had to cut short it due to time constraints, I guess. I am not like him, so I won't cut short anything. I will speak everything that I thought of speaking. So then comes the executionalism, execution and professionalism. This is what I'm going to focus on through this PPT right now. Yeah, yes. So why did we take this part? Most of the projects that we have fail because there is no coordination between the team members and we don't have documentation. I am going to stress on documentation throughout this entire presentation because it is one of the core concepts that we want the participants to to have in the hackathon. So that's the one of the reasons that we are conducting this workshop. You have to know the importance of what documentation is and how to do it. And then when you are building a project, obviously, if you are not clear about what you are doing and if you're not clear how you are doing, there will be some confusion in the system architecture. And then no clear ownership or accountability comes in a large companies, some production startups and stuff. So you have to make sure who owns what, who did what, and everything. And then results. You can have a wonderful model, you can have a wonderful website, but without presenting it well, it won't reach the audience, or at least it won't reach the right audience that you intend to reach. Okay. So to do all this, to overcome all these issues, the success, that's what everyone is aiming for, right? As shown in the PPT, success requires structure, clarity, and professional execution. Okay. So we will be focusing on it. And now I did mention about like we will need documentation and we are going to stress on it. But documentation isn't just about having a README file. Everyone must have used GitHub at this point. Okay, yeah. Before I speak about that, I would like to ask one question. How many of you are familiar with GitHub and you think you know GitHub very well? I think there is an option to raise your hands, right? Wait, I may not be able to see it here. Okay, participants list, yeah. Yeah, only 2 people. So no one else knows GitHub. Okay. 6, 7, 8. Okay. I'll wait for a few more seconds until I switch back to the presentation. Okay, let's say at least, out of all these people, at least, let's say 15 to 20 people knows GitHub. Okay. At the end of this presentation, I will ask this question again. Okay. Then you have to say whether you know GitHub or not. That is the task I have for you. Okay. So just make a note. If you have Rise in your hands, you should know that you think you know GitHub. Okay. So yes, going on with this, everyone must, if you know GitHub, you must have come across README files. You know how to do it and everything. So documentation isn't just about giving a prompt to ChatGPT, summarizing your project and putting down as a README file. It is not about it. Your documentation should clearly specify how much system memory you use. That is for especially when it comes to model training and then space accumulation and every stuff. And also data sets. For data sets, you clearly have to specify how much size it contains, what are the data types it has, and everything. And then you should focus on technical reasoning. Like let's say you have chosen something, you didn't give reason why you have chosen that. This will be a big problem, especially when you present it to a company or when you present it for a conference or a journal. When you are saying you have some novelty, when you are saying you did some research and you did some solution, you must have reason why you chose this particular pathway, why you chose this particular methodology and everything. You must have the reasoning behind every single thing that you are doing. And then of course legal record. So you must ensure that you have proper records on what you are doing. And then when it comes to companies, must make note of finance, you must make note on who did what. And then you must note whichever sources that you are using, you must use something from the others, right? So you must note what you are using and stuff. And then comes team communication. This is very, very important. Collaboration is something that we will speak next now. And industry standards. When you want to like upskill, like I already said, to some higher standard, we are all college students here. So we are just learning things. And obviously, after a few months or a few years, we are going to go to some company or some industry or research area or something. So when we want to go to such a high standard, we must meet what expectations and practices that they have. So for taking care of all these, we need proper documentation. So without proper documentation, reproducibility, reproducibility, like the if you have some code, if you want to reproduce it again the same way, it becomes impossible because you don't know what you have done, and no one else in your team knows what you have done. So if you have an idea, it's just going to be with you, and if you forget, that's it. So you can't exactly, maybe you can give all the files to a model and then you can ask it, okay, what is it about and everything. It may predict to some extent, but it can't predict the idea that you had in mind. Okay. So knowledge is wealth. The idea, every idea that you have is wealth. If you don't document it, if you just miss to note it down, it might all be in vain. Okay. So documentation is very, very important. So what do you want to document? What do you want to make note of? What do you want to record when you are doing some project? First, problem statement. Before documentation, there is the task of identifying what the problem statement is. And as of now, we are not going to delve more into that because we believe you have attended a lot of hackathons, you have attended events, so we think you know how to pick up a problem statement, how to decide on what to do in a particular domain or track. So after taking a problem statement, you have to make sure of what are the constraints present when you are working with that particular problem statement. That may be regarding the data sets, you might not have any, or that may be regarding the models or the timeline or anything, or the budget, or the systems, the OS that we have, the number of people in the team, everything could be a constraint when you are working on a project. You have to make sure on noting all these constraints and addressing them in the planning stage itself. And then comes the data source, where we mention its origin, the way we access them, the way we clean, process everything, and licensing. Licensing is something that we have to know. And next comes cleaning and pre-processing. We will speak about it now. And then decision logic, like already Raghavana said. So we have to have proper reasoning, and we have to have depth on what we are doing. So we shouldn't take some decision just because we can. Okay. Then comes AI usage. Sriniketan was briefly explaining about how to use AI, how to give prompts, what are the different types of prompts like zero prompt and everything. And then limitations. When we take a problem statement, we must know both strength as well as weakness. So we should make a note of both of it. And next, future scope. You are working on a project, you have completed it, well and good, fine. But are you done with it? Should you stop there? Or should you think what could be improved? Because everything has a scope for improvement. Everything could be improved. Nothing is going to be the final permanent end for anything. If everything had an end, then you won't have a lot of programming languages today. You won't have a lot of varieties in semiconductors or models or anything. Take anything, any app. Just take a simple Word document, a document, a file. To open it, we are having hundreds of apps now, and all of it are different in some way or the other. They might share some similarities, but still the improvements are done every single day. Like let's say we had VS Code, and now we had anti-gravity, and who knows what might comes next when it comes to coding. So some might like the old ones, some might like the new ones. It is all in their hands. But regardless of what they are doing, when they are working on some project, they can see that this could be improved, this could be changed, this could be made into something better. So that future scope you have to note down, because without noting this future scope into a proper documentation, you might miss on a key major achievement or a breakthrough that you might get. So I recommend you to also note the future scope very well when you are doing the documentation itself. So yes, like Veerana was saying, if you remember, he was showing a pipeline. There was this data collection, and then they were using this AWS thing, and he talked about OLTP, OLAP, and batch and stream processing as well. And he showed different Amazon tools like Redshift, Kinesis. If you are not familiar with AWS or Amazon or any cloud tools, they are all just different ways of accessing cloud. If you don't know what cloud is, I think this is not the time to explain, but we will share some materials to you regarding what cloud is and why is it necessary in today's circumstances and stuff. So if you didn't understand the flowchart that he was showing to you, this could give a better visualization of what it is. It is just the same things, but instead of I removed all the jargons and everything, and this is just a process. So we first acquire the data, we get it, we extract it from different sources, and then we verify it. Data verification is something we never do when we are doing a college level project. But when it comes to industry, or when it comes to a novelty or research paper or something, we definitely need to verify the data in order to ensure that we are doing our best in what we have. Okay, data verification is a very important step in nowadays data pipeline. And then comes the data cleaning, where we remove the incorrect values and we correct the uh, wrong ones. And then comes the data pre-processing. Cleaning and pre-processing are slightly different steps. And then comes the data analytics, where we analyze and interpret. Yeah, let's go back to the example that Raghavan asked. There is a data. It's just going to be solved with a SLR, simple linear regression, and then we are using some very complex model to predict it. Okay, so to avoid this, what we could have done when we had data after pre-processing, just analyzing the data, the trends in data. Data analysis is, nowadays we are saying it as just mean standard deviation and stuff. Data analytics is not that. Data analysis is a lot more thing, and it is a very vast and unique field of its own. But let's take this simple example, and even in this example, just analyzing the data and visualizing it before going for selecting the model would have been a lot better. So that should have been done. If that has been done, we could have predicted a linear relationship, and based on that, we could have selected the model. So choosing which kind of intelligence layer you want depends on all these processes. And when I say intelligence, yeah, I will get to this. When I say intelligence, after you have the data, you need to get some output from it. How are you going to get it? So we have different logics. First comes the deterministic logics, which are simple rule-based systems. We have some conditions. If this data that we have follows this condition, then we are going to give this as a result. So this is going to be deterministic. And then comes the statistical, where we have different types of hypothesis testing. The t-test and or k-test. There are a lot of tests. I don't even remember the names right now. When I'm speaking in a hurry. So yes, there are a lot of tests, there are a lot of methods that we want, and those are all statistical inferences what we are doing. And then comes the algorithmic system, where we are building some custom algorithms to solve one specific problems. This may not be the same for any other problem. For this particular set of problems, we use this. So we use this algorithm inside our system. This is one way of solving the issue. And then comes the ML based probabilistic model, and any models. Okay, so these are what we think as an intelligence layer. We take a data, we process it, and then we give the output. So this intelligence layer is very crucial, and here is where we apply everything that we learned in the session 2. Which one to use, which model to use, which method to use. If you can just give a rule-based system, and then you are using some, let's say, even a simple model as SLR, it is going to be a waste of time. Why are you doing that? You can just have an if-else condition instead of that. So you have to know what is your data and what should be your output, and you have to match both of that to know which kind of intelligence that you need in your particular system. So yes, like I have mentioned here, why this method, why not simpler, and what assumptions that we are taking to implement this particular logic. So these are something necessary. And I skipped this side earlier. So this is about data cleaning and pre-processing. I told these are different, right? So data cleaning is about focusing on data quality, integrity, and how to, processing is to prepare the data for modeling. Each model requires some kind of data to be input to it. Okay, no, we can't give any data to any model. So pre-processing is like preparing the data for readiness and correctness. And data cleaning is to ensure that the data that we have is of a good quality and it is very integrable. It has high integrity. So these are the things that we are going to ensure when we are doing data cleaning. This is data pre-processing. So this one is for ensuring reproducibility and one is for debugging. So yes, we saw this, and then like we were speaking about prompting, Sriniketan was saying about all these things. So when it comes to documenting, you just not have to document the data part and the intelligence part. Like whatever intelligence layer that you are using, any ML model or any algorithm, you have to mention in the document why you have chosen this. You have to give it the justification for it, and you have to give the trade-off, complexity analysis, and all these analysis that you have done when you are choosing a model. If you take a project, you just implement a model and say this will work good. It doesn't work that way. You have to try with different things and see which has which trade-off, which is high advantages and which is not much useful in our case. And based on that, you have to simplify things as much as possible. Simplicity, efficiency, all these are very crucial when we are building an intelligence layer. So you have to document all this. And even after documenting all this, like let's say to build this intelligent layer or to pre-process data or for any purpose in your system, you are using AI tools. Okay. And nowadays in our environment and the way we are working, you just don't have to mention the data as well as the intelligence layer. You also have to document the AI tool usage. For projects we may avoid it so as to skip the faculties and the way they scold us and stuff. But still, when it comes to industry, if you give the same prompt to different models, it is going to change. And if we are giving the same prompt to different model versions, it is still going to change. And we don't have that in our hands. So you have to mention all this, whichever model you are using, and not just for the AI tools, also for the tech stack that you are using. You have to mention the models, the way you are using, and everything into a proper document. How you are refining the data. Like let's say you are doing prompt refinement, so how it is refined, you have to mention. So also, if you use AI, so you have to note that if you review it or if you modified it, you have to also add it. So why we are doing this? Why are companies, encouraging people to do AI tool usage documentation is that it ensures transparency. Yeah, in any particular place, in any particular company or organization, transparency is something very required. So this comes under professional AI usage. So it is always recommended to also document the AI tool usage that you are doing when it comes to professional systems. So yes, then comes the topics of reproducibility and explainability. So when you are doing an experiment, you must make sure that when you are running the same input output, like same input combinations for different times across different environments, you are getting consistent results. Okay, this is going to be something crucial. And then comes the clear reasoning behind what output you are getting. And then to explain what output you are getting, you must also note down the logic. You must verify the logic that you are using in your particular system. And then comes version control and history. Like you all already know about GitHub. Git is a very common version control method that we are using. And these things, the reproducibility and explainability is very much required in industries and research. So all of us are going to go in either of these sides, right? So without these concepts, a system cannot be, trusted or, improved or maintained or anything. So going to the next concept. Till now, we have been speaking about documentation. Let's say you have done a project, you have the documentation. How can you, say that your project is truly novel? What makes your project stand out from other projects? This is something very important. And if you are into publications, patenting, and all these stuff, novelty and intellectual contribution is very essential. Even when you are working for a company, you have to make sure that your product is, novel compared to your competitor's product. So these things you have to consider. Novelty, when we speak about novelty, it is not just about saying you use this tool, you used GPT, or you used TensorFlow or Python. This is not the way you mentioned the novelty. Like there is an already existing project in Java. You did the same thing in Python. Bravo, yeah, you got a new novel product. No, it doesn't work that way. Novelty is not about the tools. It is about how you frame the problem statement and how you integrate and optimize your solution and what are the trade-offs that you have. So the design trade-offs play an important role when you are talking about novelty. So reasoning, novelty is all about reasoning, and then it is about unique problem framing, like Raghav mentioned. So nowadays people use AI for ideation. So AI is obviously going to take ideas from others' projects and is going to give to you. Then where will be novelty in your project? So okay, maybe you can ask AI to help you with understanding about a particular domain or understanding about a particular track or any problem statement. But if you ask AI to frame your problem statement or give the objective of your problem statement, it is just going to give something that is already existing. There is going to be zero novelty in what you're doing. So if you need novelty, you have to think of it. You have to add your own ideas. Okay. Human brain is more valuable than you realize. So if you just sit and think, if you just believe that you can get a new idea, you are obviously going to get it. And to get new ideas, you must first see what the existing ideas are. So this is a very long process, and if your first years or second years, it might be a little vague to see how we are going to get ideas, how we are going to bring in novel ideas into our project and all this. But once you start working, you're obviously going to get the flow of how to work with a project. Okay, so yeah. Then, if you are saying you have a novel idea, and then you don't want any other to say that, okay, this is my idea. Like, let's say I did a project, and Sriniketan is coming and saying he did the same project before me. I know I did it before, but what proof I have? What do I have to protect my right toward the project that I did? Okay, so that's where copyright comes into the picture and copyright protection comes into the picture. So your code, your documentation, your design, these all are qualified for copyrights. So when you are and there are two things to consider. One, when you have a novelty and you don't want anyone else to steal your thing, copyright is important. And also, when you are taking references or when you are copy pasting code from someone else, if you don't properly attribute them, or if you don't see the license compatibility, you are going to be affected by the copyright rules. In some places, if it is very extreme, when it comes to companies, if you use something without proper attribution, they might even sue you and you might have to pay fines and stuff. So all these things might come into picture. And one of the most common things that people do is that they don't see if they have the proper authorization to access something, a code or data set or anything. So to ensure proper authorization is to skip unnecessary copyright issues. And then ignoring license term when you are using other party libraries, like Python has a vast set of libraries, and yeah, most of them are going to be open source, but some, they might have some modifications, and they might have some catches in their license. So if you are using it and if you are publishing a paper and you are not giving them the proper attribute, like you have used this and they are responsible for creating that particular library, they might ask you for something, they might complain against you. So copyright protection is something that is very serious, and you have to consider it when you are working with some novelty. Then comes open source licenses. Like we say there are copyrights. Then what about the rules that we are using nowadays? Like let's say Python again, for example. So open source licenses define how we can use a software. And when we say open source, it means that people are allowed to use it, without any cost, without any, constraints. But open source doesn't mean it gives you the entire access to what you are using. So that's where license come into picture. In GitHub, there is something called license. We all will give if we need, like if you have used GitHub, you will go when you are creating a repository, it will ask for git ignore, and then below it, it will ask if you want to add a license. And most commonly used is going to be MIT license for us because it is the most permissive license that we have, compared to other things. And it only requires attribution. If you just take someone's code, you are just going to attribute to them, and that's it. You don't need any other thing. But something else like Apache or GPL, they are all there is something called copy left, and we need, like if you're using GPL, if you are using someone else's code, like if that, let's say there is person A who has done given GPL license for their work, and if person B is taking person A's work and implementing in their project, GPL ensures that person B's work should also be open source. Okay, so these are some conditions that we have. So there are a lot of licenses. Now we don't have the time to speak about all this. You can always search it up in Google, or you can just give a prompt, and any model is going to be ready to answer you stuff. So before using any library in your project, always check if that license and its properties are compatible with your needs, your company or your organization or your project's needs, and then use it. Okay, so this comes to also the case where you are giving a license to your project. So you have to make sure how people want to use your project. So based on that, give the license. So yes, this is about license. And yeah, in the beginning stages, if you are using GitHub, if you want to, there are two kinds of things that we may usually have. Always include a license file, obviously, in a GitHub. And then when you want, most simple and most permissive license, use MIT license. And if you're working on some research paper, or if you want some novelty, or if you want some patent protection, it is commonly recommended to use Apache Rumito. Okay, so choose one of this and work like that. And also, always when you use someone else's code, show professionalism. Like add the credit that they deserve. It's their work. You are using it. So have some professional ethic to address that this is their work and we have used just a thank you note. That's it. That's all you can do. They are giving you the code for free. They are giving you an open source code. Just thank them. Just cite them. That's it. That's not going to take any of your time. So do this. So be professional in what you're doing. There is a comparison between open source and paid tools. I think we don't have the time to delve into it. I will skip into this. We will share the PPTs anyways with you, so you can always see that. And then also, like we were speaking about professionalism, make sure to maintain, code quality and industry standards, naming conventions. That's the very first thing any computer science students would learn in their 12th grade. Python has different name, camel case, Pascal case, all this. So naming conventions, know where to use what, use clear descriptive name for your variables or your constants or class names or anything. And always make sure to bake your code into modular structure. In this particular hackathon, we are also going to consider, modularity of your, your submission. So make sure that your code is highly understandable and, highly modular so that it is very much understandable and each component has a simple or single responsibility only. And yeah, that's almost the same as what clean hierarchy is, but it's just about organizing files into proper way. And readme we already discussed, basic testing we already discussed, and even Sriniketan was saying about data simulation, where we also started bringing a tools to generate data to test it. So these are some standards, and when we are doing the testing, make sure to note down that as well. Okay, so this is the way we do. And yeah, note this line very much. Like this was something that is always in my mind. So when you do a project, don't do it to finish your assignment or finish your work or just to win the hacker. When you do a project, do it with some love and this feel to have the system up and running for years to come. Okay. So if you do in this way, you are obviously on the right track to becoming a professional coder or professional, a professional in general. So yes, and then there comes deployment. This is one meme I always found funny. Okay, introducing Vipon, the largest vibe coding conference, and they gave this link. So can someone say what's wrong with this?
It's hosted
It's a
locally.
local host.
Yes, exactly. So anyone who has worked with hosting a website knows that this is a local hosted website. So this is what happens if you don't know what you're doing. Just if you do vibe coding and if you just, have a link and you say, yeah, I got a link and you are sharing to people, people won't be able to open it. So yes, you have to know what is it. So if you have done a project locally and if you want it to share to others, then comes this concept of deployment, right? So what deployment is in a simple terms is that, let's say you have a recipe. Okay, very simple example. You have a recipe and you want to share it to your friend. I like paneer butter masala much, and I say that I'm going to do it to my friend. And he just hears these three words. Okay, paneer butter masala or anything. Okay, just hears the word, mixes all of these things. Is he going to get it? No, right? There is a proper procedure, there is a proper setup, the timings, everything matters. So when you are sending recipe to your friend, you will make sure to send all these tools, I mean the ingredients, and then the timings and the utensils that you have used, the exact measurements, the environment in which you cooked, and all these matters. And that is where containers, the Docker and everything comes into picture. So Docker is all about creating a containerization of your code, so that if it runs in a Docker container, it can run anywhere, wherever Docker exists. So this is a very vast topic on itself. I just added this in the slide so that you know what deployment is. Okay, so note this down. So if you are deploying your project and adding your link in the overview of the submission, please know what deployment actually is. Okay. So if you can even improve your project by using Docker or anything to improve it. And then comes the concept of CI/CD. I will just add some links for your reference. What CI/CD is, what DevOps is, what DevSecOps is. These terms are going to be very recurring when you go to an industry. Okay, it's not, everything is not about just taking a project, building it, showing the output. There is a vast pipeline called CI/CD, which you have to know. I will share both this PPT as well as the links for it. So then comes the ethical and responsible AI. Just read through these slides when you have the time and know how you are going to use AI. Like we already said for the past, half an hour or 1.5 hours or something. Okay. Know where biases come into picture when you are training a model or when you are making a decision. Make sure of explainability, make sure of data privacy. Privacy is something that is lacking nowadays in all the projects that we are doing. Cybersecurity is a very vast concept, but we can try to include privacy, authentication, RBAC, they say, role-based authentication. I think I had it in my next slides, so it will come. So privacy is something very important. So make sure the whatever project you are doing, it is secure and safe enough. The data is safe. And yes, this is the pipeline that we are focusing today. Okay. Uh, the reason the professional speakers spoke for just 1 hour, and I have been speaking here for the past 45 minutes, is that they spoke on these two topics. Okay, data and intelligence. I am trying to convey all these 6 topics to you. So yes, it is a bit vast. I know. I think I took a lot of your time, but I just need to share things to you in a way that you understand. Okay, so this is the pipeline that we focused on, the screening, integration, and then we took this data, and here's where the intelligence comes into picture. And then for all of these things, we use AI tools, and documentation is required throughout the entire process. Collaboration, that's where version controls come into picture. Legal clarity, deployment, and professional system is when all these are integrated into a single part. So yes, this is what system means. System, like we asked the first question, right? If you just code, is it a system? No. A proper professional system must contain all these 7 steps at first. Then only it becomes a proper production ready system. Okay. So this is a very structural, very, reliable and maintainable system that can give real value to the user or to the owner or anyone. Okay. So we were speaking about collaboration. The hackathon team is going to be of 3 or 4, right? But collaboration isn't just about being a part of your team. It is about collaborating with anyone who is doing the project alongside you. When you are in a company, you are not going to be the only one who is doing a project. There are a lot of people going to work, and you might work on just one part of your project, right? So then, in that case, collaboration comes as a very major technical skill that is required. So you need to track the progress, and you need to address any technical disagreements you have with any other team. And code merging, this is where GitHub comes into picture. Anyone who has used pull requests knows why we are doing it. And then communication, which person to should work on which part, and which part should be completed first, and task allocation comes into picture. So this is what team works when it comes to a technical project or technical system building. So collaboration is much important, and GitHub comes into the picture when you are speaking about collaboration. And GitHub is useful for tracking changes, enabling rollback, and then preventing overwrite when you are doing a project, and parallel development as well. So you all know GitHub, right? And now you must have been familiar with this main branch, dev branch, and when you are doing the branching pull request, and how you are maintaining stability, accountability, and traceability. But do you know these? GitHub isn't just about version control. Yes, Git is for version control, and GitHub extends beyond version control. It has the issues feature to, you know, track the bugs, to solve the problems, and get comments, and assign the tasks. So issues is a very major thing. And then comes the projects where you can visualize using Kanban boards for workflow visualization, and going from one stage to another, and moving tasks from having a lot of backlogs to completing everything. So projects is much important, and collaborators gives granular permissions. And you also have the option to create an organization. GitHub organization is something that allows different people to work on a single project. You can have a lot of repositories inside a single organization, and that is something. And then review comments. GitHub allows this. So you said GitHub, right? How many of you have actually worked with any one of these at least? Oh, I mean, switch to that tab to see. Okay, one, two, three, four. That's nice, nice. Lot more than what I expected, actually. Six people, seven. Okay, probably you might have used GitHub issues, right? That's the most probable thing that you use. Collaborator you must have used. Apart from collaborator, don't include collaborator. If you say you use collaborator and you are saying that you have used these tools, then it doesn't make sense. I included collaborator because it is something basic. Without collaborators, if you had used issues or GitHub actions, then you can raise your hands. Yeah. Okay,
Discussion
so
form.
that what?
Discussion forms.
Okay, discussion, yeah. Forums, right? So that is something, yeah, GitHub is a very, collaborative platform. Even if you're working as a single person, to know others' projects, to know their works, to discuss with others' works, and everything, it is so good. Okay, GitHub is a very nice platform. If you know everything in GitHub, then that basically means you are ready for any industry level thing. Okay, because to work with every aspect of GitHub, you have to work with a lot of tech stack, a lot of projects and stuff. Okay, so yeah, just one or okay. So yes, like we are saying, we need to have all these features in GitHub, and we can use it to the maximum efficiency. Okay, then also comes the database sharing and data governance. Veerana spoke about this, why data governance is needed, so that we can include this data integrity, accountability, and security. He mentioned these 3 points, and go through these slides if you want to know more about these. And then there are different types of databases, and also we have different security and access controls like RBAC. And git ignore is very important if you want to hide the sensitive files from being uploaded to the repositories. And API key protection, you have to use it, especially when you are working with some paid tools. Okay, if someone misuses your API key, you are going to be the one to pay finally. And there are a lot of cases happening regarding this. People recently issued a complaints against Google as well, because someone mistook took their API key and used it, and they are being billed millions of dollars. So API key protection is something very important. So make sure of doing that, and environment variables as well, and planning and project management tools. So we said all this right at this point. For the past 2 hours we have been speaking, and it might be very vast and long, and you might not know how to organize stuff. And that's where project management comes into picture. We have two type of management. One comes to planning and project management, another comes the time management. Okay, so unlike me, who has took about 1 hour extra, you don't have the time. Okay, you have to make sure that you have to complete everything within the given time. Let's take for the hackathon for 24 hours. You can't ask for a 48 hours, right? You have to complete all the tasks within the given time. So task clarity, timeline visibility, and dependency management should be there. Notion is a very good tool, like many people recommend. I also recommend. So and Gantt charts could be used for giving the pipelines and other tools here given as well. So yes, then comes the time scheduling. Let me just speak in general. You have the 5 minute rule, and then you have the Pomodoro technique. 5 minute rule is something that I like very much. I usually procrastinate when there is a topic that I don't have much interest about, so I don't start working on it. And then this 5 minute rule I came across somewhere, and it said that just make up your mind to sit on something for 5 minutes. If you have full concentration over those 5 minutes, and if you did something well, and you will automatically have the interest to continue with that work, and you will read more about it, and you will eventually finish it. So basically, this 5 minute rule is to avoid procrastination when you don't have interest in something. So try this out. So also there is the Pomodoro technique, and 20 minutes code and 5 minutes break and everything. And maintain your environment. When it comes to office, even HR and other people, your managers will look into it. You are working on a very cluttered environment. People might think you don't have much, scheduling or proper responsibility when it comes to your task. And it's not just about others. It's also about you. If you have things cluttered in your system or outside your system, so you are not going to know what is where, and you are going to struggle when you are choosing stuff, right? So environment design is something important, and energy management, more than time management, energy management should be important. Okay, and when I say energy management, it's about when doing which task and which is doable right now. So focus on energy management. And when you plan for any project, like I was saying about project management and planning, right? You have three types of tasks. One comes the daily task, basic level. Today, what I have to do, tomorrow, what I have to do, and all this. And then project level. Okay, if I do all these things within a particular duration, I will be completing this project. So overall, what is my project and how I have to complete it? And apart from these two levels, you have the higher level, your vision, what you want to do in academically, what you want to do for yourself. So you have to have this vision, and inside this vision, you have different projects, different tasks that you have, and for each task, you have to allot time every day. Okay. So by allotting time, effectively, then only you are able to complete tasks. And when it comes to hackathons, these are very competitive environments. Like in our hackathon, the registrations were closed yesterday, and we got about 400 teams which have registered, and we don't know how the evaluators are going to evaluate, honestly. But still, there is a lot of competition, right? There are people from different states, different teams, different colleges, and when you are working in such a competitive environment, if you give your work without much planning, the teams, whoever is working, are not going to complete their work properly. They are going to do different. If there is a team of four, they are going to do things which are mismatched, and then they are not going to have much time, and they are not going to polish and present their work well. So all this happens without planning. And when it comes to a general hackathon, first thing that you want to do is that probably there are going to be 4 or 5 stages, right? First, focus on the core features, and then go about integrating all those core features, and then test it out, find out the errors, find out the cases which might have been left out, and then prepare your demo. Preparation is very much important when you want to present your work. Go through your work. Even if you have completed a very big system, if you don't know how to present it, you are not going to get in anywhere. Let it be a company, let it be an interview, internship, or a hackathon, anything. Presentation is must. Present in a understandable, legible, and a friendly way. Okay. And it should be professional. When we are talking about all these academic stuff, it should be friendly as well as professional. You have to balance both of these. Okay. So with all these planning, you can definitely achieve, the milestones, your tasks, your goals, and you can do everything without the time. And then you can even prepare your presentations, and you can present it, and you can achieve anything. So yeah, I did say this is about hackathons, but this is about your daily life as well. Plan things, do well, and you are obviously going to achieve in it. Okay. I think I took a lot of your time, but you could be happy because I'm going to stop talking right now. So this is your time to ask any questions that you have to me. And I thank you all for, patiently staying up and listening to every rant that I was doing. Anyone here? Everyone slept away. Was
We
I
are
talking too
here.
long? Yeah. Okay.
Yeah, I really appreciate the fact that you are very elaborate with your presentation. It was insightful.
Thank you. I just wanted to, cover every aspect of what we aimed when we were discussing about this hackathon. This hackathon, like I said, this, steps that you want to do in a hackathon, right? This is not going to work when we come to our hackathon. You are not going to work with just giving a prototype and then working stage by stage. And that's not the way we are doing it, because we need you to learn something more. We need you to, test yourself in competitive environments, to push your boundaries and move forward. Okay, that is our aim, and that is the whole objective behind having this hackathon, right? So I hope almost all of you here are participants of that hackathon, and I personally wish you all the very best to give your presentations, and I hope all these insights will be useful for you to get to the offline round as well. So whoever is getting selected, see you there. Anyone else, any questions, any comments that you want to add to me or any of the speakers? You are welcome to speak.
Any
At least
questions about the hackathon
ah,
as well?
yeah, you can ask about the hackathon. Or if you can just give some utterance that you are still alive after hearing all our presentations, you can be react. Okay, at least someone laughs and someone, claps their hands. Others, I think they are probably, under dream world or something. Yeah, I can see a lot of responses now. Thank you. Any questions about the hackathon? How many of you did your submissions till now? Anyone who completed their submissions? No one, right? Okay, so when you are working on the project, try to, include anything that you learned from today's session into your submission, and then that might be useful for you, and that might even make your solution even better. But if you can't, no need to, worry about, whether I didn't include anything from what they said. Am I going to get selected or not? This is not about using what is being said. This is about thinking and understanding what you need. So think what you need and decide as per that. So when it comes to further projects, have all these in your mind. It might be clustered till now, and you might not be confused. You might be confused on what to do when. Just think about it. Just plan and then do it. That's it. Okay.
Thank you very much, Gautam and Sriniketan. It was quite truly enriching. Ashita, I guess you're muted.
And with that, we come to the end of today's workshop, Beyond the Code. We hope this session offered meaningful insights and fresh perspective on technology beyond coding.
As we move forward towards TetherX, we encourage all participants to give their best, apply today's learnings, and collaborate efficiently with your teams. Refine your ideas, build confidently, and make sure to submit your projects as early as possible. Remember, impactful solutions come from clarity, creativity, and teamwork.
Thank you everyone for joining us today, and everyone kindly register on the Event Hub website to get your certificates. We wish you all the very best for the upcoming hackathon and have a very wonderful evening ahead. Thank you everyone.
Also, we will be sharing the feedback form in the WhatsApp group. Kindly fill that.